Hello, everyone, and welcome to the November edition of Techspert Talks. I'm Troy Rainey, and I'll be your host for today's session. Today's Techspert Talk session is Build on Iceberg with Qlik Open Lakehouse with our own Jason Hall. Jason, why don't you tell us a little bit about yourself?
Thanks for having me, Troy. So, name is Jason Hall. I came to Qlik in January as a part of an acquisition of a company called Upsolver. Upsolver had about a decade's worth of experience helping customers manage high-scale, real-time data lakes, specifically focused around Iceberg, hence the topic of today's conversations. We've spent the last several months integrating the Upsolver technology into Qlik Talend Cloud, specifically the Qlik Open Lakehouse capabilities. Yeah, happy to be here.
Yeah, thank you so much for being here. Today, Jason's going to talk to us about why Iceberg and why now. He's going to take us through a demo of how to build an open lakehouse. We're going to look at some ways of querying that data in the lakehouse and mirroring it and some other additional things to remember. Now, Jason, I've heard a lot of people talking about data lakehouses and why they're great, but why is it the topic of conversation now?
Yeah, so it's an interesting time in kind of the data architecture journey. Data volumes increase and customers start thinking about needing to store multiple terabytes, hundreds of terabytes, even petabytes worth of data. Storing that data in a traditional data warehouse gets very expensive. Data lakes are really a great way to store very large volumes of data in a very cost-effective way. Several years ago, some of the first data lakes were built on technologies like Hadoop, right? It was much less expensive. The challenge with those data lakes of several decades ago was that all of the money you might have saved on the warehouse, you then spent sometimes orders of magnitude more in complexity.
Well, that all makes sense. What's changed recently to make now a good time to move to that kind of data architecture?
I think there's really two factors that have made data lakes now much more of a commonplace architecture for many customers. The first is the widespread adoption of cloud technologies, right? Cloud infrastructure is so much less expensive, so much easier to install and maintain, and fairly universally well supported across the industry. And specifically, cloud technologies like object storage, Amazon S3, GCS. Object storage just makes it extremely simple and extremely inexpensive to set up petabytes worth of disk that we can now store data on. The second factor is newer open table formats that can now store data inside of a data lake architecture. I would say the infrastructure has gotten a lot simpler and more cost efficient due to cloud architectures, and the complexity has lessened due to some of the advancements that have been made in open table formats.
Okay. Cloud's more adopted and accepted. Iceberg's got a better format. It reduces the complexity. How does this fit in with Qlik?
Historically, Qlik on the data integration side has moved data around existing data platforms. Qlik kind of acknowledged lakehouses as a cost-effective way to store data. Increased interest of lakehouse technologies made Qlik interested in providing customers an option of let's ingest your high-scale, low-latency data into Iceberg once. And Qlik has standardized on Iceberg as its table format for a variety of reasons. Then all of these different data platforms can simply connect into Iceberg to consume and query that data. And there's a lot of cost efficiency that comes from that, less duplication of data, right? I got one copy of my data. I know that it's consistent because there's only one of them, but it's really centered around giving customers a choice. Now you have this open lakehouse option to ingest data at high scale in near real time at a very efficient cost.
What does the Iceberg architecture look like?
Yeah, so the center of this slide references the Qlik Talend Cloud infrastructure and specifically the Qlik Open Lakehouse, right, which runs inside of Qlik Talend Cloud. On the left, you've got your data sources like Salesforce or Workday or some of the SaaS applications that your business might rely on. Databases like Oracle, SQL Server, PostgreSQL, SAP systems or mainframe systems. And the Lakehouse architecture will then ingest all of that data in real time into Iceberg tables. Over on the right, you have all of the different consumption engines or query engines that can now connect to the Qlik Open Lakehouse to run queries against those tables. And this could be Snowflake, Databricks, Redshift. These could be query engines like Apache Spark or Trino or Presto or Starburst. One of the benefits of Qlik managing its open lakehouse using the Apache Iceberg format is that widespread adoption that you'll see from the consumption engines on the right. So the idea is you can bring high scale real time data into Iceberg, and then all of the different query and consumption engines can consume data from the open lakehouse architecture.
And I guess Cloud Analytics would be one of those engines that could
Yeah, so
pull stuff.
absolutely. So there's a variety of ways that you could connect Qlik Cloud Analytics to the open lakehouse. One that we've seen fairly successful for organizations is leveraging a connector to a AWS Athena. Athena very well supports Iceberg. Qlik Cloud Analytics can then query and access data from the Qlik Open Lakehouse.
Very cool. Well, I would love to take a look at how you build one of these lake houses inside Qlik Talend Cloud. Do you have some data we can ingest? Okay,
Yes.
so what are we looking at here? It looks like we're on your tenant and we're in the data
Yeah,
integration side.
exactly. So I'm right now inside of a Qlik Talend Cloud tenant. Qlik Open Lakehouse runs as a data platform option within Qlik Talend Cloud. We will go ahead and create a new project,
All right.
and I will give my project a name and put this into my space here. This project will be a data pipeline project for real-time ingestion, and you'll see in the data platform here reference to Qlik Open Lakehouse. We want to provide customers choices. It's not the only
Okay.
option for building a pipeline project. And there's three connections that we'll define within this project. The first is a connection to a data catalog. The data catalog is important for Iceberg as a component of the architecture that stores metadata associated with the tables and their locations. We're going to choose the AWS Glue data catalog here in this example. Connecting to a catalog is very straightforward. Select the region that your catalog runs in, the bucket that you want to store your Iceberg tables in, and how you want to authenticate to the catalog itself.
And a catalog, is that just how it reads metadata?
Yeah, it's a good way to think of it. And within Iceberg, the purpose of the catalog, if I'm going to very oversimplify it,
Uh-huh.
is to present tables and their locations to a query engine.
That makes sense. Thanks. Okay, and the next connection we need?
Yep. The next connection we need is what's referred to as a landing connection. Any data pipeline project that ingests real-time data in Qlik Talend Cloud will leverage a landing connection. And this is where raw data is going to get loaded prior to it being processed into Iceberg.
Okay.
This is really just a storage location, specifically in this use case, S3. There's a component we call our data movement gateway that will ingest data from the source. It will take that raw data and store it in the landing location. And then the Iceberg processing components will pick that data up from the landing location and process it into Iceberg.
But that could be any one of many options for target connections.
Absolutely. Yeah. And then the third component we need here, and this is an important component, it's what we call our Lakehouse cluster. So in order to process data into Iceberg, that data needs to be processed via compute resources, and these compute resources run inside of the customer's cloud infrastructure. So no data is going to leave the customer's network. And that
But
is very much a preferred architecture for any customer who's security conscious. Right?
okay.
You don't need to send Qlik your data. Your data will never sit on Qlik servers. That data will be processed again within the infrastructure that the customer is running their open lakehouse on. So I will simply choose that cluster that we've pre-configured here. And now I've got my project defined. So with kind of the shell of the project defined, now I'll go through a data onboarding process where I can choose any number of data sources. Qlik Talend Cloud supports dozens of data sources, API endpoints, relational databases, SAP or mainframe systems. But in my case, what I'll choose is a CDC use case coming from a PostgreSQL database.
Okay.
The wizard here will now allow me to select specifically how many tables that I want to ingest. I can make my
Hmm.
selection here, either a selection by checking off the actual tables or maybe including string patterns that we can use to match on specific tables that I want to include or exclude from this pipeline.
Okay. And I see those all support CDC. Is that?
Absolutely, yeah. So we're going to be doing real-time ingestion from Postgres. So here's where we actually make that selection. Within this pipeline, change data capture will give us that real-time processing using those write-ahead logs. So we'll choose change data capture.
Okay.
And then this history option is an important one. Type 2, if I want to maintain accessibility to all of the different updates and potentially deletes that happen to that single key column, I can choose to maintain type 2 characteristics of data. Gives you a lot of
Yeah.
stability around seeing the lineage of row level changes, as well as we might want to use that historical data in various types of transformations.
Yeah. To me, the having the governance of type 2 sounds so much more attractive.
Absolutely. I'd much rather have it than not, unless the use case just simply doesn't need it.
Sure.
We have a summary of our project. We've now laid out the project, we've onboarded our data, and we will now set up the different processes needed in order to process this data into Iceberg. We now have our source connection over on the left. That source data will move into landing, effectively the S3 bucket that will store raw data. And then over here on the right, we have the storage process. This is the task that will process that data into Iceberg tables. 3 tasks now laid out within a data pipeline.
Okay. We'll just prepare it and actually get it into Iceberg.
Yeah, exactly. Rather than kind of make you wait through that preparation and kickoff process, I'll just jump to really the same project and you can see what a running pipeline looks like.
Great.
Postgres system over on the left, processing data into landing here. Again, then processing that data into Iceberg using the second task here. If I look at the task level details, here are the tables that I'm ingesting down at the bottom. We do
Yeah.
a full load of each table and apply that into Iceberg. And then from that point forward, we then rely on CDC.
Okay. It loads once, and then after that initial full load, it'll just process the changes. And I see it looks like this has been running for a while because I see a lot of process changes.
Exactly. Yeah. This is a fairly low volume, but it has been running for a while now. So you'll see changes start as incoming changes. So
Okay.
these are changes that we've detected from the source that have yet to be processed into Iceberg. We will then see those changes processed into Iceberg. So any change that's processed is now available for consumption.
What is the unoptimized changes?
Yeah, good question. And we haven't talked about optimization specifically yet, but all Iceberg is a format. It's a definition of how to store data and how to store metadata that makes those tables queryable. Iceberg needs to be optimized. And there's a variety of optimizations that are recommended by Iceberg itself in order to make sure tables are performing well. There's a second feature there that we call the Qlik Adaptive Optimizer. And this adaptive optimizer is handling all of the very difficult work in the background continuously, making sure that Iceberg is performing as well as it can when queried and consumed. So
Ah,
these unoptimized changes are effectively those that have been written but have not yet been run through the optimizer. You'll rarely see 0 there, but the goal of the optimizer is to keep that number of changes low so that you get good query performance on the resulting tables.
and maybe it's not a direct correlation, but 776 versus 132,000, that's less than 1%.
Yeah, exactly. These optimizations are triggering continuously. We're not wasting resources by running optimizations when they're not needed.
Okay. Can we jump back to that project and see what that looked like? So what is the mirror task you got on the end there?
Yeah, great question. So the mirror task is optional.
Right.
The Iceberg tables are being written into and optimized by the storage task. And Iceberg tables independently can be queried by any number of query engines. But we may now want to take these Iceberg tables that we've ingested into and optimized via Open Lakehouse and query that data from a data warehouse. So that's where this mirror task comes in. In this example, this is a Snowflake task. And the goal of the mirror task is to create objects in the data warehouse, in this case, Snowflake, that point back to the Open Lakehouse table and allow that data to be queried and consumed by Snowflake. The mirror titling there is really important because it is not a copy of the data sent to Snowflake. That's
Okay.
traditionally how this would be done. Okay, now we've got 2 copies of the data. We're paying twice for it. We didn't want to do that here. The mirror is a reflection of data in Snowflake. If I stand in front of a mirror, there's not 2 Jasons, right? There's one
Right.
Jason and the mirror is a reflection of myself. So That's what this is. So I can set up a mirror task. If I look at the task itself, we've got our data sets here that are loaded into Snowflake as a mirror. But if I actually look at what these data sets are, it is creating what Snowflake calls an external Iceberg table that points back to my Iceberg catalog and the external volume, which is where my Iceberg table is stored. But this object now allows you to run a query in Snowflake against a mirror where that data is actually being returned from your Open Lakehouse Iceberg tables.
Okay, so it presents that data to whoever wants to query it.
Exactly. But remember, we're ingesting this data into the Open Lakehouse. We're not using data warehouse resources to handle that ingestion. We're
Uh-huh.
simply now creating a mirror in the data warehouse that lets us run queries against the Iceberg tables whenever we need to consume or work with that data.
That is so cool. Could you go back, open up that task? Looked like there were some options there. So this allows you to create some transformation rules as well as a part of this task?
Yeah. So transformations are certainly core to the Qlik Talend Cloud platform. I like to call these task level transformations, or I sometimes call them inline transformations.
Right.
You can rename tables, you can change data types of various columns. Here you can see an example where I'm converting the name of this table to uppercase, right? Snowflake really
Okay.
likes uppercase table names. Now, the name of this table is uppercase when it's mirrored into Snowflake. And you can apply these at any task level. For example, if I go into my Iceberg storage task, I may add a
Oh,
transformation rule that converts a data type from a number to a string. Maybe the source Postgres column is numeric, but I want to treat it as a string in my output table. Or the replace column value can be really useful too. I was actually working with a customer just the other day where in some of their rows of data, the United States was referenced as USA. In some rows of data, it was referenced as US. So they wanted the storage task to effectively normalize that data within the transformation rule.
that's a cool example. I can imagine the frustration of such a subtle difference causing problems downstream.
Absolutely, yeah.
What is that dotted line at the end there?
So what this dotted line references here is a cross-project transformation task. If I go to this particular project, I now
Okay.
have a transformation project that reads data from my Open Lakehouse tables
Hmm.
and then creates additional transformations on top of it.
Okay, so it uses those snowflake tables as the source for an additional
Exactly. We're
project.
using the Snowflake mirrors is a good way to think of it, right? Because
Uh-huh.
again, this data is not in Snowflake. It's a mirror
Yeah,
that points back to Open Lakehouse, but it appears in Snowflake as a mirror that we can now point to and query from to perform additional downstream transformations. So I can maybe filter out bad data. I'm running some cleansing functions to maybe mask PII or sensitive information. Maybe I want to do my data normalization here, that country code example. And then maybe my final result now is I want to create an aggregate table. And now I've got my gold kind of data mart that I can run analytics against.
I love that concept that it's loaded once, it's available for multiple projects, and you're able to use that data, but it's all still coming from the same source, that open lakehouse.
Exactly. And not even just multiple projects. Let's ingest our data once. Let's serve that data up to multiple pipeline projects, but maybe even different engines itself.
Yeah.
I
Yeah.
was working with a customer the other day who was really interested in ingesting the raw data into Iceberg and then using open source, very inexpensive query engines like Athena or possibly even open source Spark to do raw data analysis, right? Forensic type queries against that system using one query engine. But then they also had data transformation tasks that they wanted to leverage Snowflake for. So ingest the data once and then even have multiple engines consuming that same data for various purposes.
That's very cool. Gives you a lot of options. Great. Now it's time for Q&A. Please submit your questions to the Q&A panel on the left-hand side of your On24 console. I'll just take these one at a time. First question. Do you need a Qlik Talend Cloud subscription for this feature?
Yeah, good question. So Qlik Open Lakehouse that we've discussed on this session here is an option within Qlik Talend Cloud. So yes, it is not a separate product. You would need a Qlik Talend Cloud subscription. We do
Hmm.
support all of the different subscription tiers other than starter. But if you're on standard or up, then you would have access to the Qlik Open Lakehouse within your Qlik Talend Cloud subscription.
Great. Next question. Can Qlik Open Lakehouse help optimize a pre-existing Iceberg implementation?
So not yet, but that is an interesting idea that we're currently considering on our roadmap. Right
Okay.
now, the Qlik Open Lakehouse is tasked with processing and optimizing data that Qlik Talend Cloud ingests. But it is something that we've had some interesting conversations with customers about, possibly allowing you to run the adaptive optimizer on top of existing Iceberg implementations. Stay tuned. No concrete plans for it, but it is something that we're discussing.
Okay, great. Next question. What is the best way to monitor the latency of Iceberg tasks? Can you set up notifications if latency drops to a set level?
Yeah, good question. So you'll see that for this project, we've got the landing and the storage task, each with metrics that indicate effectively how far behind is that task to
Okay.
current. Now, these tasks do run continuously. That's an important concept. I want to make sure I hammer home here. There's no scheduling of landing and storage tasks. They run continuously 24 by 7 using those compute resources within the cluster. Of course, if there's any failure associated with any of these tasks, the error messages and failure statuses would be shown in the UI here. And of course, you may start to see the data freshness fall behind. We also have monitor views that you can configure that
Oh,
will give
okay.
you more of a global view across all of your pipeline projects. And then also you have the ability to set up notifications and alerts on failures or errors or latencies that you might have across each of the different tasks.
Okay, great. So that is possible.
Yep.
Wonderful. Next question. Would this be a possible solution for big data, as in queries against billions of rows?
Yes, absolutely. And I would almost argue that the value proposition is even stronger as big data type initiatives are being considered by customers. The real, I would say, sweet spot of Open Lakehouse and where Iceberg really becomes, I don't want to say a no-brainer, but starts to approach that
Uh-huh.
is not just in terms of data volume, when we start to think about multi-terabyte use cases, but more so in terms of data freshness and real-time data, specifically data coming from like CDC type sources or streaming sources like Kafka or Kinesis, because when you start to have data that's not only approaching that terabyte plus scale, but also near real-time freshness, data warehouses get really, really expensive. So leveraging something like Open Lakehouse to offload ingestion processing from the warehouse into the lakehouse is a really cost-effective value proposition. And also at that terabyte plus scale and at near real-time freshness, the need to run continuous optimization on Iceberg also is extremely high.
Great. This one looks a little specific. How can I change data from SAP with a 1,000 format to a format like 1.000?
Oh, I gotcha. Yeah, so that would be a data transformation use case. There's a variety of ways to handle that. SAP likes to store data in specific formats. You may want to preserve that format in your
Hmm.
bronze layer when you ingest into Iceberg. But if you recall those transformation tasks that we saw in the project, if we want to store that data in Iceberg in a completely different format at ingestion time, we can set up one of those inline transformations to just simply convert the data type. Or if we want to actually change the data itself, change it from 1000 to 1.00, we could
Hmm.
replace the column value and then just simply set up an expression that handles the conversion that we want to perform. That would be
Great.
one way through a transformation rule in the storage task itself. Another way would be to take advantage of the full pipeline project workflow that we showed earlier, where you ingest it as raw and then you leverage a separate transform process to take that data and convert it into whatever format it needs to be in.
Great. That's perfect. Next question. How is Iceberg different from Databrick Lakehouse like Delta GCP?
Okay, interesting. So this is an important distinction. So Iceberg is a table format. All
Right.
right. These table formats, they define how data should be stored and how metadata can be created to make that data queryable and consumable.
Okay.
Databricks is a data platform. So Databricks will support a lakehouse that uses Iceberg, right? Databricks also can support a lakehouse that uses Delta. Many of these data platforms now allow you to choose different table formats You mentioned GCP there too. Iceberg can run on GCP, it can run on Azure, it can run on AWS. So you've got a few different choices as it becomes clear here, right? What's your table format you want to leverage to run your lakehouse? What's the cloud platform you want to run your lakehouse on? And then finally, what is your query engine or data platform that you want to use for, consumption or processing of that data? And there's options across all three. Making
Yeah,
a decision is use case dependent on what the use case is that you're trying to run your data platform through.
great. Well, thank you for clarifying that. Next question. What sort of security is there on the Qlik Open Lakehouse?
So security is handled at a couple different levels. Within Qlik Talend Cloud, there's a security model for authentication and access that's very well established. I guess the unique component of Qlik Talend Cloud relevant to this conversation today is what we discussed within the Qlik Open Lakehouse. And if I
Hmm.
actually bring up the Lakehouse cluster section of the interface here, you can see that Lakehouse clusters run within network integrations. A network integration is something that you set up within Qlik Talend Cloud that points Qlik to your cloud infrastructure. So if I
Okay.
actually look at one of these network integrations and specifically the details here, you'll see I've configured a few subnets within my cloud infrastructure. I've configured a encryption key that Qlik is going to use to encrypt and decrypt data within your cloud infrastructure. There's an S3 bucket within your cloud infrastructure that data is stored in. There are various roles and security groups that set up authentication and firewall level restrictions within the cloud infrastructure. Much of the security around data access
Hmm.
is up to you. It's based on how you secure your cloud infrastructure because all of the data processing happens within your cloud infrastructure. And again, that's very much a preference for most security conscious organizations. You're not sending any data to Qlik in order for us to process that data on Qlik servers. And you manage all of the security controls on top of that network integration.
That's a really important aspect. That's cool. We're not moving it. It just stays there. All the data, the processing is happening on your network.
Absolutely. Yeah. We've talked to a lot of security conscious customers who told us point blank, if we need to send you our data, we cannot use your solution.
Yeah, that
Right.
makes
So,
sense.
which makes sense, right? So they want to make sure they maintain full control, full governance, and full security controls on top of that data. And that's the way that we've built out this architecture.
Perfect. Next question. Regarding capacity licensing, is the data counted on this initial full load only, or when the data is loaded into an analytics app, or both?
There's a bit of it depends in that answer. From the Qlik Talend Cloud Open Lakehouse side, the capacity-based licensing is based on ingested data volume. So how much data are you ingesting into Iceberg?
Okay.
From the analytics side, it would depend a bit upon what query engine you're using and how does that query engine interface with the data. If you use, for example, an Athena engine, you would only essentially be billed by how much data Athena is querying from the Iceberg tables. And then once that data is in analytics, all of the different ways that you slice and dice it would be independent from that.
Okay, great. Next question. What's the benefit of creating a data mart from Iceberg, or is it even necessary?
It could be, yeah. So it depends on the use case specifically. There are certain use cases where your ingestion from the source into an Iceberg table is now presenting that data in a way that's directly consumable, right? We've got a source table in Postgres, and we simply want to bring that data into Iceberg so that we can run queries against it. The pipeline project is really just tasked with bringing in data from a source and processing that data into Iceberg. There's also data architecture scenarios where you do want to bring that data in from raw, then maybe filter out some bad data to improve quality, normalize some data, cleanse the data. Then maybe I need to join multiple tables together and aggregate it into a data mart so that it can now be analytics ready and consumed by the analytics engine.
Great. And last question we have time for today. Is it possible to have some integration with automation as part of the data flow?
Yeah, absolutely. I mean, the data is the data, right? Example that I'm actually working on right now with the Qlik team,
Okay.
where we want to set up automated notifications to end users based on the data that appears in the Iceberg tables that we're processing data into. For example, we're ingesting data into a table. That data contains information about specific users within our system, and then we want to trigger automations based on when a new user shows up in that system and what the data is associated with each user. Having this data in Iceberg, again, allows us to use that data for a variety of purposes and from a variety of engines.
Very cool. And it's great having that as an option as a part of the Qlik Cloud platform. Yeah, Jason, thank you so much for putting this together. It was a great demo, and you've clarified a lot of what I didn't know ahead of time. So to me, that was very complicated, but you made it seem pretty clear. I appreciate it.
Yeah, no, I appreciate it. And definitely want to thank the audience for the participation today and all the good questions that were sent our way. Qlik Open Lakehouse is not a new product, right? It's a feature of Qlik Talend Cloud. So anyone out there who is a Qlik Talend Cloud customer or user, you now have access to Qlik Open Lakehouse. And we certainly encourage you to initially kind of think through where lakehouses might fit into your data strategy. And of course, if you think there is a fit, try it out. There's no added license cost or subscription needed in order to try out Qlik Open Lakehouse. For those that are not Qlik Talend Cloud customers, if you do have Lakehouse initiatives, maybe this is a good reason to think through your data integration strategy and see if and where an Iceberg formatted Lakehouse fits in. So you can find me and reach out if you'd like to chat further, or of course, there's lots of information available out on the Qlik website. Just look up Qlik Talend Cloud and Qlik Open Lakehouse. Lots of good resources available and lots of ways that you can connect with us if you'd like to discuss further. Thanks everyone for your time today. I really appreciate the interaction.
Great. Thank you, everyone. We hope you enjoyed this session. And special thanks to Jason for presenting. We always appreciate getting experts like Jason to share with us. Here's our legal disclaimer. And thank you once again. Have a great rest of your day.